Good morning to everyone that has joined in this webinar, and welcome to this webinar on the role of the new UK technologies in connectivity, which is being organized by the UK Telecommunications Innovation Network, or UK-TIN for short. This is the second webinar in a series of pre-Mobile World Congress webinars organized by UK-TIN. And today's objective for us and the great panelists that are joining us in this is to give you an early snapshot or a heads up on what you'd be able to hear and see and also experience if you visit the organization and the projects presented here at MWC. Very, very briefly, a bit of an introduction on the UK-TIN. UK-TIN is the UK National Coordination Activity funded by DCIT, by the Department for Science, Innovation and Technology, with the single purpose to provide a front door function to the thriving research, development and innovation future communication ecosystem in the UK, encompassing industry, academia and research and technology organizations like Digital Catapult. One of the key activities of UK-TIN is the coordination of the UK future capability in the telecommunications sector, working through public consultation with experts across the ecosystem to generate a potential technology roadmap for telecommunication systems in the UK in the research, development and innovation space. The UK government, through the Department for Science, Innovation and Technology, has been investing significantly in the past 8 years in the development of new capabilities and technologies in the area of communication systems, from optical communications to network management. This investment across academia and industry has generated already some very specific and significant capabilities and advances, and a subset of these will be covered today by our esteemed panelists, with the only criteria for selecting this is to provide a snapshot view, again, saying it again, on what you'll be able to hear, see, or experience in the MWC presence of these UK activities. To cover all of this, we have a great panel representing the key UK research, development and innovation activities in the UK. And I will introduce the panelists one by one. They will introduce the key innovations from their projects with their partners, and then they will answer a few questions, including questions from the audience. Please use the Q&A panel for posting your questions, and we will address them within the time that we have. The starting question for the introduction of the projects from all of the panelists is to introduce themselves briefly, to cover their projects and technology research and technology focus, and the application and demos that might be available at MWC, to learn more and to discuss and potentially start new collaboration. By way of introducing myself, I am Dritan Kaleshi. I'm Director of Technology for 5G at Digital Catapult, and I am one of the founders of the UK Telecommunication Innovation Network, and I am chairing this panel today from that particular angle. So without further ado, I want to invite Professor Tim O'Farrell, Professor of Wireless Communications at University of Sheffield, that will speak on the fascinatingly named Your-RAN project and other activities. Tim, over to you.
Thank you very much, Dritan. A pleasure to be here and a pleasure to have the opportunity to speak on behalf of the Your-RAN project. My name is Tim O'Farrell, as Dritan said. I'm a professor at the University of Sheffield. I'm also the Keysight Royal Academy of Engineering Research Chair in 6G Air Interface Technologies. So this project is very much in line with that, and I'm delighted to be able to explain what Your-RAN is. Your-RAN is an abbreviation for Yorkshire Open Radio Access Networks. It's a project which represents a particular region of the UK, the large county of Yorkshire, and a very vibrant cluster of companies, telecommunication companies, who are members of this consortium, who are working on mobile cellular technology aimed at Open RAN. The project itself, our main focus is one which is directed towards producing technologies for neutral host networks. And a major aspect of that activity is focusing on the energy efficiency of our technology solutions. So the project is led by the University of York and Professor Alistair Burr, who oversees the project. Um, I myself am the work package one leader, which is to do with radio units. And the whole project is structured on 6 major work packages, primarily technology work packages, which are work package one on radio units, work package two on the physical layer disaggregation, work package three on RIC developments, and then really the remaining work packages are about bringing our technologies together as we're actually building technologies and integrating them into an overall open RAN solution. And then we've developed test beds and have taken the technology to trials. And that technology which we've developed is what we'll be going on to show at Mobile World Congress. So first of all, let me say a little bit about the ORAN radio units that we've been developing. What's of particular interest there to us is that we've put a lot of effort into developing what we call concurrent dual band or multi-band radio units, which are targeted to neutral hosts so that we can operate across the N78, N77 upper bands in the UK, supporting those bands simultaneously through a single RF fabric. And that's work which is particularly being done in terms of new developments at the University of Sheffield. But we're working closely with our industrial partners, Slipstream, which is a small, medium-sized enterprise, which is developing software-defined radio units for Open RAN. And they've developed a particular unit which is capable of T8 transmitters and R8 receivers. And that's complemented by technology produced by Radio Design, which is looking at dual band tunable RF filters, which is filters which can act concurrently and tune in to the N78 and the N77 upper band. That technology which has been developed there now is mature, and Slipstream and Radio Design are particularly interested in taking that to market, while our efforts at Sheffield are also being taken into an exploitation avenue. Moving on from there into the fire disaggregation, this particular work package is run by the University of York, and this is looking at front haul compression in the Open RAN context and introducing new algorithms to improve the compression efficiency of the front haul. A major aspect of this work package also is looking at distributed massive MIMO in the cell-free massive MIMO concept. This is one of the first projects to address this in the Open RAN context and take into account the Open RAN conditions on the development of cell-free massive MIMO. And these technologies have been brought together into overall system-level modeling, looking in particular at certain 6G use cases. The third main work package there is called RIC development, and there we're introducing an AI capability into the XAPPs and the RAP. We have a particular AI engine for doing that, and we have an XAPP which is particularly focused on energy saving capabilities, controlling the disaggregated PHY and the radio. All of this technology has been brought together here on the bottom right to demonstrate at Mobile World Congress. So we're going to be there in a stand which will show a cell-free massive MIMO demonstrator, a real-time closed-loop control on the machine using the technology we've developed. And that technology will include ORAN radio units, including some millimeter wave front ends looking at 72 gigahertz E-band, as really pushing the technology into future 6G applications.
Thank you.
So thank you, Ditran.
Thank you, Tim. Thank you very, very much. And moving on very quickly, introducing David Griffin, Dr. David Griffin, a lead researcher in computer networks at University College London, to speak about Tudor. David, over to you. 5 minutes, please.
Thanks very much. Hi, everybody. Okay, I'm David Griffin. I'm a leader of one of the work packages in Tudor. So Tudor is a relatively large project. There are about 20 participants. I won't go through everybody. It's being led by the University of Surrey. But I'm standing in for them today to present the project. So overall, the project is about developing what we call 3D networks. So 3D networks is an extension of terrestrial mobile networks to include airborne and satellite segments of the network, and to seamlessly integrate them together so that there is easy handover for the users from using the terrestrial network to using network supported by airborne drones or by satellites, typically low Earth orbit satellites. The intention of this is to deliver a seamless and integrated network which will increase the coverage and increase the reliability of mobile communications into underserved regions. So both within developed countries and also outside, in the middle of the ocean, you will be able to connect to 6G networks and get seamless connectivity as if you were in the middle of an urban area. So ultimately, it is to deliver a more reliable and resilient wireless communication, providing both indoor and outdoor coverage, and to incorporate some new 6G features. So in terms of demos that we'll be showing at Mobile World Congress, there are 3 main demos, which is going to be backed up with some other videos for other parts of the project. But 3 of the features that we intend to have demos specifically on is on semantic communications, auto-scaling, and spectrum sensing. So the first one about semantic communications. So semantic communications is all about, rather than sending symbols that represent the actual content of the data that you want to communicate, it is about encoding it in a different way about the meaning of the content. So this is a relatively new field. It's a very active sort of research field in how to encode video and audio and high definition content in this new semantic way of doing things. It's possible to reduce data rates to about 1/10 of their current requirement. So this has obvious benefits in being able to fit more highly demanding flows into the same amount of bandwidth, or to increase the quality using the existing bandwidth. So the reason this is useful is that we can, in non-terrestrial networks where you've got more constrained communications going up to satellites, there is potentially less bandwidth, there's potentially more noise, the signal can be isn't necessarily as strong because you're going over greater distances. There's also weather effects that come into play. So ultimately there can be fairly harsh channel conditions. And so the efficiency and effectiveness of the semantic communications needs to be adapted to those conditions. The techniques that we developed allow us to adapt to particular signal-to-noise ratio conditions and to make the semantic communications work effectively in both airborne and non-terrestrial environments. So this is the first major demo. The second one is on AI-driven auto-scaling. So here we have a network operations center. So the network operations center is essentially the brains of a communications network. This is where the management and the orchestration is done. So the underlying network capabilities these days is provided by software, which is running in commodity clouds rather than in physical boxes, which used to be done in the olden days. So with these virtual functions, the AI-driven auto-scaling can expand or can increase the quantity of them as and when they are needed. So we can have a more efficient deployment of network functions according to the actual usage to reduce energy and increase efficiency. The third demo is about spectrum sensing. So the project has developed a system on a chip which increases the granularity of sensing the radio spectrum, increasing its granularity in terms of time, space, and frequency, which can monitor the spectrum and how it is used, which allows for a more efficient use of spectrum, which is especially useful for radio communications and shared environments such as satellite networks. Okay, that's everything for now. So please, if you want to see more, ask more questions, and certainly come to see us in Mobile World Congress.
Yeah, thank you very much, David. And I understand the impossible task on describing very, very large projects in the tune of between 8 and 15 million pounds in about 5 minutes. So you are doing fantastic job so far. So moving over to Professor Dimitra Simonidou, Director of the Smart Internet Lab at University of Bristol, so to talk about reason. Dimitra?
So I'm going to spend 5 minutes exactly to talk about the reason. Is the third of the large FNRC investments. The other two is the ones that you heard, that is Yoran and Tudor. So reason stands for realizing emerging architectures and solutions for open networks. It involves a big partnership across industry and academia. It is led by academia and University of Bristol, indicating that this is really low TRL technologies that we are addressing. It is a large project that we are delivering in 2 years with an end of March 2025. So we are finishing in a couple of months' time. And the really reason is there to actually drive consensus of 6G open network architectures, and specifically to focus on how UK-born technologies could influence and actually catalyze these architectures. If we go to the next slide, which is my main slide. So what are the key targets? The 3 technology areas that we are working in reason. The first one is multi-access or multi-technology access. We strongly believe that when we are looking at 6G, cellular and radio is not going to be the only access technology choice. So we are looking at solutions that bring and integrate together new radio, old radio, but also emerging Wi-Fi, Li-Fi, and fiber. And we are developing solutions that actually they seamlessly integrate and intelligently control these technologies together, so we can actually provide not only seamless connectivity in the access side, but also use multiple technologies to enhance uplink capacity as well for emerging applications. Of course, AI and edge compute is very important in delivering that multi-access environment. The second one is AI native networks. So of course, AI is being addressed everywhere, but the stand in the Reason project is we would like to see ways to optimizing AI end-to-end. So we believe that local actually optimization with AI does not deliver global optimization if we add everything together, so that end-to-end intelligence, and we are producing toolkits, for instance, that they are looking at AI orchestration and cognitive orchestration across the network. And the third one, we are looking at UK-born technologies and how these technologies could contribute into the future 6G narrative. So, and these technologies are new fibers, for instance, hollow core fiber. We have worked with Compound Semiconductor in South Wales, and we have produced new devices for RF, for optical, for power amplifiers. We have enhanced optical, wireless, and Li-Fi, and we are looking at some positioning of quantum services, especially in the Open RAN front haul. So what you are going to see at MWC from Reason, of course, we are going to have a Reason stand where we are going to demonstrating architectural elements that we are producing with our industrial partners into our project. From our project. So the first demonstration is going to be, as far as I know, the world first volumetric, wireless volumetric video, 3D video production. So we are bringing 48 cameras. The 48 cameras are connecting to multiple access technologies, Open RAN, Wi-Fi 7, and Li-Fi. this connectivity is actually provide enough capacity to the uplink to stream all these 48 streams to the edge compute. Edge compute is providing native intelligence for synchronization of the streams and rendering, and we are producing real-time holograms. So come to get your holograms, which then we can send it, and you can actually experience it even in your mobile phone. The second one, this is we are working with Nokia, and we are delivering actually industrial metaverse digital twin, where we are bringing a warehouse with our multi-access technologies, and you can see a lot of robots doing different tasks enabled by natural language models, where we are going to tell them, for instance, to tidy up, to extinguish fires, and you're going to see this happening in this environment. And the last one, we are going to give you a digital twin of a Milton Keynes Stadium and an app which has been actually developed by our partner Meta, where users can experience, first of all, the game in the digital twin. Secondly, they can compose 3D experience from different streams, fully customized for the end user. It's going to be fun in our stand, so I hope we see you there. Thank you.
Thank you. Thank you very much. Thank you very much, Dimitra. And introducing now Professor Dominic O'Brien, Professor of Engineering Science and lead of Optical Communications Group at University of Oxford, talking about one of the three pillars of the UK government interventions in the UK in telecommunications. Dominic, over to you.
Thanks very much for giving me the opportunity to be here. So I'm representing the Federated Telecommunications Hubs. This is a grouping of more than 40 universities and probably more than 100 industrial partners. We're funded by EPSRC and DCIT. So we consist of 4 elements, and you can see these on the right hand of your slide. There are 3 hubs focusing on different aspects of the telecommunications stack. So I lead a hub called HASC, and that looks at new end-to-end connectivity. That's both optical and RF. There's a hub called Titan, which really focuses on networks of networks. That's led by Harold Haas at the University of Cambridge. And then at the top, there's a hub called Cheddar, and that's looking at the edge fog cloud continuum, and that's led by Julie McCann at Imperial College. So we sort of divide up and cover all of the telecommunications stack, if you will. Another element of the program is a fantastic experimental infrastructure that's being developed at the moment called Joiner, and that's led by Dimitra, who you've just heard from. And that connects many of the labs within the consortia, but also provides more than that as a sort of living experimental infrastructure that can provide end-to-end connectivity, real-time demonstration, and at-scale experimentation. Bringing us all together is this Federated Telecoms Hub activity. That focuses on the things we need to do to create impact from our research. So things like innovation and commercialization, knowledge sharing, standards, and training. The Federated Telecoms Hub will have a stand at Mobile World Congress, so you can see live demonstrations of human activity sensing over 6G infrastructure, novel free space communications using solar cells as detectors, and looking at spectrum sharing algorithms, and also we'll demonstrate the potential of the Joiner infrastructure to accelerate that spectrum sharing research, should I say. Now, there's some live demonstrations. We have a limited amount of space and a lot to show, but there'll also be in-depth videos and lots of in-depth discussion for people if they want it. So I really encourage you to come along and see our stand as part of this wider UK effort that we're very pleased to be a part of. I'll leave it there.
Thank you very, very much, Dominic. And also thank you for using the time very wisely. Thanks. The last one, but definitely not least, is Dr. Kostas Katsaros, Head of Future Networks at Digital Catapult, who will be speaking about the Center of Excellence in Telecoms Innovation in the Catapult. Kostas, over to you.
Thanks, Dritan, and good afternoon, everyone. As Dritan mentioned, I'm Kostas Katsaros. I'm the Head of Technology for Future Networks at Digital Catapult, where we have set up the Center of Excellence in Telecoms Innovation. Our mission is to advance the UK development and use of data-driven open networks. And to do so, we have built our own R&D capabilities, focusing on orchestration network management, telecom AI and test and verification, open networks overall with APIs as focus, with the sustainability and energy efficiency being a primary objective of the world and UK government. We are also focusing on energy efficient networks, and we see the convergence of digital infrastructure with the advent of telco cloud. So these are what our R&D capabilities are, and we participate in projects like Reason that was presented earlier, but also we lead the Sonic Labs, which is a flagship project on Open RAN testing and experimentation. We also have other projects that have now kickstarted, like the SustainNet Guardian, the 60 leaders on European funded projects. Apart from the R&D capabilities, we are also focusing and trying to support the UK ecosystem, the innovation ecosystem, and the research translation. What was said earlier by Dominic on what needs to be done to explore and take the research out of academia and startups to the market. And we're doing so by enabling innovators and SMEs make use of advanced facilities like the testbeds that we have, and support them with technically underpinned programs like the TAP programs, the Technology Acceleration Programs, which we run across the UK. One is the Open RAN vendor integration and testing through Sonic Labs, so focusing purely on Open RAN integration and vendors that bring from radios to CUs, DUs, and RIC, or develop applications for the RIC, to 5G Immersive Lab in northeast of England, and the Smart Nano program in Northern Ireland, where we're focusing on the adoption of 5G in different sectors of the UK economy. Finally, through UK18, we are coordinating the work that needs to be done on the future capabilities in order to deliver a proactive and public input to the UK government policy and strategy for future communication systems. During Mobile World Congress, we will be demonstrating and showcasing effectively in our virtual demo a tour of our lab so that you can feel and see what it looks like in our labs.
Thank you very much, Kostas, and thank you, everyone that's presented here. May I invite all of the panelists to effectively come forward on video. And if you are in a relatively quiet space, also, if you unmute your microphones, that would be fantastic. Even for someone that it is working very, very closely with the rest of the UK ecosystem, sometimes I feel when I hear all that presentation a bit of a head spinning. So I say this quite formally and quite publicly at this moment in time, also knowing that this is just skimming on the surface of the real depth and the work that is being done. Also, it is very, very obvious, but what you see presented here today is absolutely everyone in the UK that it is working in advanced communication systems and solutions, from the area that team covered on radio units and RIC and physical disaggregation, to network management in Reason and multi-access, to new connectivity in HASC, to network of networks, and to the 3D networking that David mentioned. It is, without any doubt, one of the most organized and broad coverage of research areas, behind which sits more than 45 to 48 universities, and in my opinion, more than 30 or 40 industrial organizations that participate in the various activities that we effectively flagged here. And this is something that you'll experience if you go to Mobile World Congress. I'll start with a question, but I want to encourage people to also put questions on the Q&A, which I will read out and ask the panelists. But my first question to the panelists, with tremendous thanks on covering your brief so well, is there is a space around the telecoms that the telecoms is crucial for, it's part of a critical national infrastructure. We can't think of any aspect of life without any connectivity. But at the same time, there needs to be a need for interpreting and presenting more and more on what the innovations that you are working, you and your partners and your colleagues are working about, what these innovations means for the industry at large, but also for consumers and the society. What is your projected impact on the great research? What do you see coming out of this as the work progresses in the future? I'll start from Tim purely because that's the way it appears on my screen. Tim, please.
Yes, thanks very much, Drita. Yes, I think there's certainly several key things coming out of the ORAN project. One of the very large things we want to emphasize is we represent a key RF cluster in the UK, something which is a kind of a spillover from the heydays of Filtronic and the cellular mobile industry. There's now a lot of RF companies which are interested in producing RF technologies based in what's called the Shipley Glen, which is a kind of centre of RF technology in the UK. And the work we've been doing on ORAN here has been very much taking ORAN radio unit technologies to the next stage. As I said in my presentation, particularly focused on the neutral host application. In other words, users, use cases, applications which want flexibility in the radio units. And that's what we're doing. We're providing flexible capabilities to tune into multiple bands concurrently with designs which are energy efficient, low RF footprint, and so helping to address the sustainability and the cost of the unit. And this is having quite a significant impact. So now that we're coming to the end of the project, we're talking to a lot of radio unit vendors in the community out there, both nationally and internationally. And we're certainly gauging traction through this technology in order to really bring it to market. I certainly know that Slipstream and Radio Design now are very close to having products developed from this, which we want to see out there and be part of the ORAN market. On the other side, the flip side, which is worth mentioning, is we've also looked very much at the 6G end. So we've got millimeter wave technologies being developed on the RF side. And all of this is being put into context with respect to the RIC and the networking aspects, this disaggregation, so the problem of the bandwidth constraints on the front haul. And when you bring all of this together, what we've been very much working towards is a full Open RAN enhancement, which again would go towards that neutral network capability. So that's what we've been driving out, Dieter, and that's what we want to get out there.
Thank you so much. Thank you so much, Tim. Can I present the same question, Dominic, to you? Second on my screen. Again, continuing on the theme of the connectivity, but also more broadly.
So I think we're a very broad set of hubs covering all of the telecom stack. So there's a range of impacts. I think in the nearer term, it's things like data sets input to standards, open sourcing of certain amounts of the work we're doing. And there are some startups in the offing. We can see some innovation and some in the short term, some startups coming out of it as well. Those are a few examples. I think in the longer term, we're developing new technologies for the longer term, things like maturing terahertz as a means to communicate new sorts of optical fiber, bringing quantum into the world of wired and wireless as well, innovations in networks and innovations in compute. I'd be here all day if I listed all of the impacts. Of course, I'll leave it there with just those few.
Thank you, but also picking up on for the title on the new K technologies in a space or in an era where AI has now become de facto tool that can be translated and used in many others. How do you see? So I will go to Dimitri and then David and Kostas. How do you see this the work that you are doing in this particular space? Any particular impact, Dimitri, on industry, society, and consumers?
Yes, so Reason is from the beginning a very strong partnership between industry and academia and industry. And really, we are seeing ourselves as a big advocate of software for networks. And I think that is an area which is going to see tremendous growth, much more than hardware as we are moving into the new generation. That is my opinion. And of course, software toolkits leveraging AI is a very big area that we are going to see a big opportunity. So Reason is actually developing breakthrough solutions on software for networks, cloud telco. At the moment, we are having 76 inventions or intellectual property assets in our list. We also have made 2 contributions to 3GPP standards already. Now, those are just mentioning numbers, but the most important thing is within industry and academia, the UK has a strong voice and leadership of what AI for networks is going to look like. And I'm very proud to say that actually Reason is leading this conversation and providing these insights. For instance, in the new ITU AI group, we are extremely active, bringing in contributions and really thought leadership. So, and that is not from the academics only, that is really with the key vendors, Ericsson, Nokia, Samsung, but also collaboration with BT, with our SMEs and so on. So I'll stop there.
Thank you, Dimitri. And David, kind of same question as all of the other panelists.
Okay, so from the Tudor point of view, so the main thing we work on is 3D networks. Okay, so by integrating terrestrial, sort of airborne and satellite networks, we're increasing coverage and reliability of mobile communications, because we know that mobile, we even just moving around the UK, you have very patchy coverage, right? So coverage everywhere in the UK and indeed worldwide will increase sort of the connectivity of users and of their applications, so that things like AI-enabled services are available to everybody the whole time. By sharing the resources of satellites, okay, or of cloud computing environments. Dimitri talked about softwareization and making use of telco clouds. By sharing that infrastructure, it reduces the costs for mobile operators, so reducing capital expenditure and startup costs, and also enables greater resilience, because you can make use of these other software. You can deploy your software on different cloud providers. Regarding the semantic communications, reducing the data rate, improving quality, obviously increases the speed up of the deployment of extended reality, virtual reality, high bandwidth demanding services. So we can increase and speed up the deployment of those. The AI-driven auto-scaling, this increases resource efficiency. You only use the resources that you need when you need them, but you can expand them as time goes by. And from the point of view of spectrum sensing, I mean, a big benefit there is by having a finer grained view of how spectrum is being used, we can have a much more efficient use of sort of the precious resource of the radio spectrum.
Thank you, David. And Kostas, in all of this, I know kind of from an orchestration and an AI native architecture space, we are very much involved. But at the same time, if you look at what Tim described as having a real-time closed loop control of machinery as part of the demonstration, or the neuromorphic volumetric capture video that Dimitra described, as well as David and Dominic, where do you see kind of the value created to close the chain from the underground to wireless to the 3D networks and the network management in the middle? Where does it go to be used?
You need the end users, you need the industry to adopt all those new innovations, and in order to do so, you need to have the facilities and the exposure of those innovations to the SMEs, to the largest industry, and that's, for example, what we are doing through the innovation programs that we run, or what is being done through Titan and the other federated hubs. So the support of the SMEs to experience the future, what is coming in the future, because the operators won't have these capabilities, not at least for the next 10 years. You need to prepare them soon, and that is through using testbeds, using R&D facilities. but also in terms of making sure that in terms of resiliency, we know that, different speakers presented the role of AI for the networks. We see that with the advent of AI for the networks and within the networks, you need to be able to manage that and how you orchestrate the network, the AI within the networks, how you test the different capabilities of AI and making sure that they are verified, explainable, and observable. And that is something that needs to be developed as a capability.
Thank you very much. I will want to kind of ask some couple of questions from the audience, and they are kind of potentially to be answered quickly because I know that some activities are being done on this. So I'll probably go to specific panelists members on this. So there is a question from the audience, which is how are all these UK projects and activities going to be promoted in Horizon Europe context and follow on scale ups at Mobile World Congress? What are the plans leading into that? And I would want to combine that also with what is more of a suggestion than a question, which is planning to meet the smart network services. So Dimitra, your hand is up, so I'll start with you, but at the same time, the same question to all of you as to what is the connection to Europe and to Horizon Europe from your perspective on these activities. Dimitra.
The reason I put my hand up is because I don't want to forget that actually there is a webinar organized by 6GIA coming Friday the 24th, and probably we can share the link, Mary, with our audience so they can attend, where actually the purpose of the webinar is to promote the UK capability, the hubs, the projects, the infrastructures, which include more than what we're discussing today, into our European partners and specifically the 6GIA members, so they can consider and encourage partnership from the UK in the next call, SNS call in particular, which is in April. So that is the first. Please attend that webinar. We are going to provide a link so you can register. If you have also any suggestions of things that you would like us to promote, send it so we can include it in the presentations. So that is the first. In terms of how I see that we are actually aligned with our European partners, I think there's a very good alignment. I think also there is quite a valuable contribution from the UK on topics from the technology side all the way to the software layers. We also have very strong research infrastructure proposition, and that is going beyond Joiner, of course, include Joiner to what Dominic described, but also we have UKTL, we are having Sonic Labs, we have the National Dark Fiber Facility. It's something that I believe we are richer than Europe at the moment, and therefore we can contributing towards some leading experience into the European program. And I'll stop here so others could talk as well.
Please. Tim, your hand is up, and please, panelists, please give me an indication to pass on to you. Tim.
Yes, yeah. I mean, one of the key ways we want to get involved in this is through the advanced manufacturing research catapults. So you mentioned this briefly in terms of part of our demo at Mobile World Congress. We'll have the numerically controlled machines, but AMRC provides us that really advanced use case where we're looking at 5G, 6G in the advanced manufacturing environment, the time critical applications there, which mean very, very low latency. All of this speaks to these advances in the AI, the actual technology in the hardware itself, its response times. And these provide an excellent platform to engage with some of the European partners with similar profiles to actually do joint research and to connect up with these. And we've been reaching out through the various SNS seminars. There was one in London recently. Dimitra's mentioned this one. And these give us a way to try to engage. And certainly AMRC, which is actually based in Sheffield, is one way that we'll be pushing to participate in that. Thank you.
Thank you. Anyone else from the panel? Okay. Let me move on also with another kind of question from the audience, which is around and the way that Tim and Dimitra described, and all of you described until now, the capabilities and the foundational from experimental infrastructure to kind of deep research in leading into specific implementation and potential spin-outs or contributions to industry and standardization, from radio and optical to network management and anything between. It is very, very obvious. However, and that's what I will use as a context, is, do the panelists believe, there is a question from the audience, do the panelists believe that the UK will continue to lead in the research, development and innovation in quote unquote telecoms and connectivity in the future? Or is our success based on a continued collaboration abroad? Abroad meaning interpreting it as internationally. The role of the international collaboration, in particularly in taking forward some of the fundamental and applied research advances that are being made in the UK. What does the panel think that particular role is, and how do you think we will address it? Kostas?
Yes, we need to work with our partners, be it in the UK or internationally. You cannot lead in this space. Even the other countries that are being seen as leaders, they all work in collaboration with others, and you explore the synergies. So we do have expertise and we do have leadership in certain areas where we have the capabilities, from academia to some industry, but we do need to work with others where we have gaps. It's what we have identified through the UK team and the future capabilities reports that have been published, the SWOT analysis in the last year, and what we are doing now, where we have strengths and where we have weaknesses. We are aware of those, and building the capabilities only internally, only in the UK, although may give us some sovereignty, may not give us leadership. That is kind of my view.
Thank you, Kostas. And Dominic?
I think there's also the point that we want to attract people here, that actually people coming into the UK is a good thing for us, getting skills from abroad, investment from abroad, and that's attracted through leadership in certain areas, I think, as well. So we talked about gaps where we need to collaborate because there's a gap, but also I think there's the other argument that where you have strength, people will come to you, and that's all to the good.
Thank you. And Dimitra, over to you.
Yes, I mean, it's natural to collaborate when you have gaps. I think I agree with Dominic. There is a lot of benefit to collaborate when you have strengths as well, because you amplify strengths. So if you would like a targeted collaboration with like-minded countries, it is very important. And I think it's going to become more and more important. We are a small country. We have leadership in some things, but not in everything. But also we need this partnership for expanding our capability in key areas of that we would like actually to research and to lead. So that's something I hope that we are going to see more collaboration with Europe for sure, but with other countries also, that they are bringing, they are leading as well. For instance, give an example, US and AI research and how we convert these AI assets into telecoms. I could say that that's a no-brainer for collaboration, and we have to do similar analysis across all like-minded countries.
Thank you. And Tim, over to you.
Yeah, it's very much following on that point, because we're already engaging strongly with the US and that AI side. That's part of the portfolio. And I'd like to mention the India side as well. So the UK has strong programs developing research and research activities with India, and we're also working with Korea. So we see this as both as international globally, and a very strong axis into Europe and the capabilities within Europe. Thank you.
That's fantastic. Thanks. And David.
Thanks. Fine. I agree with what you've been saying. I mean, much of our work, it's something that we can't just do by ourselves. It needs to be done in a collaborative way. We're collaborating with our partners inside the UK, but we also have to collaborate with partners in Europe and the rest of the world. But one particular angle from the Tudor point of view is because we're talking about 3D networks. If you're talking about satellite networks aren't regional, right? They're global by definition, and so we have to work together. I mean, that satellite network spans every country in the world, so there needs to be sort of common understandings, common technology, and we need to collaborate on making these work.
Thank you very much. I'm looking at some of the kind of questions, and there are more in terms of the comments online. So I will, in the closing, kind of 5-6 minutes, please, 5 minutes, and very briefly, 1 minute from every panelist. It kind of follows, the question follows from this international dimension. There is very significant investment that is being done across the world in various areas. Which, as many of you said, in some areas UK has strengths, in some areas it wants to have strengths, and in some other areas it can benefit from kind of aligning and accessing the technology. How can, because you are going into Mobile World Congress, which is effectively an industry trade show, and apparently one of the greatest shows on earth at the moment. I haven't been to Taylor Swift yet, so I don't know how it compares. But coming back to this, how in 1 minute, how do you see it connected to the impact in the international? How can you see the world make use of what the UK, what you are developing, from what kind of commercial models and investment will be required in that, in 1 minute, if that is possible, from everyone? Anyone wants to start?
Okay, maybe I can make a quick start. So from Jeff, regarding the 3 demos, regarding semantic communications, this is still in the very early stages of research. We seek specific collaboration with industry to try to resolve some of the issues, such as high semantic decoding latency. Regarding AI auto-scaling, we have a platform that can be used by smaller operators to help deploy and test their AI solutions. So I think that there's plenty of opportunity for collaboration with industry to take things further out of the lab and into real-world deployments.
Thank you. And in order, Dimitra, and then Tim.
Right. I think that we are going to have a very attractive presentation collectively at MWC, showing a lot of new technologies and attractive applications. I'm sure many others are going to do more, to show more attractive applications, because they spend millions and millions for the MWC preparation. I think where we are very attractive at this point in the UK is that we are presenting a very connected ecosystem, and a very connected ecosystem across excellence in academia, interesting SMEs. 2 of these SMEs are going to be in the region stand presenting as well, and good collaboration with industry. If I see such a also quite a good openness, engagement for regulation and policy from the UK government and our regulator, if I see an ecosystem like this, I would like to go collaborate and be and investing into it. So that connectivity as a message, I think, should be a strong message to make us more investable. And UK team probably should actually lead with this message, as they are the federated hubs and the other projects as well. I think that is our biggest quality at the moment. It is a personal opinion, but I think it's a very strong message that we can communicate.
Thank you very much. And Tim, and then Kostas.
Yeah, so briefly, I mean, we really are looking forward to the demonstration Mobile World Congress, because we brought together the solutions from this project into something which will show the different aspects of the RIC, working AI RIC, working with the AMRC numerically controlled machining side, with the cell-free massive MIMO, with our radio units embedded. And there's things there which are talking about radio units which are very mature, which can already talk into potential companies to exploit. There is the cell-free side, which BT is very interested in, and this is influencing standards going forward, front hole compression. And we're having spin-outs on this AI RIC side, which is very exciting because we see that as a potential aspect where something very rapidly could be adopted from a commercial point of view for the RICs. So we're quite interested to see our demo showcasing these points of exploitation going forward. Thank you.
Thank you very much, Tim. And Kostas and Dominic, if we can be brief, I need a 30-second to close down the time available.
For us, I'll echo Dimitra's point that we are very attractive, and the important is that what we will be showing is something tangible. It is real, and whoever wants to make use of the facilities, the Joiner, the Sonic Labs, and other facilities, they are open for collaboration experimentation.
Thank you, Kostas. Dominic?
I'll add one point. Of course,
yeah.
we have access to fantastic skills in addition to this. The collaborative, connected nature, enthusiastic people wanting to collaborate.
Thank you so much, everyone, and thank you everyone that followed the webinar, and thank you for coming today. As I said at the beginning, this is a very, very, very specific small snapshot of what you will experience if you visit Mobile World Congress. But don't wait until then. Please reach out to not just the people in the panel, but all of the partnerships that they have presented today. I can't agree more with what all of the panelists said in terms of the current status of research, development, and innovation in the UK. It's very open. It's very connected. You have the details on where to visit all of the panelists and their representative organizations. And I want to remind you for the next webinar. Thank you so much for attending today. Thank you so much to the panelists for all of the views given and the presentations today and the preparation required to cover this. With this, I close the webinar, and thank you, and hope to see you all soon, very soon.